Okay, so hello guys. Today I'll be doing February March 20 paper 2, excuse me. So let's get started with question number 1. So over here it says group 2 metals form alkaline solutions on water. Write the equation for the reaction of calcium oxide with water. So calcium oxide with water. Now moving ahead, let's start. So calcium oxide plus water gives us what? Calcium hydroxide. Now let me change the pen color so I understand it better. I'm sorry. So calcium has +2 charge on it and OH has -1, so this +2 will move over here without the charge, which is positive and +2, and this -1 charge will move over here. I'm sure you guys know that, but if you don't, then please pay attention. This is +1, so overall the answer will be CaOH whole twice. Now let's balance it. This is Ca, this is also Ca, O2, and H2 means this is also H, and over here it's 2. So this one is balanced. Now moving on to the second part, it says identify the ion that causes an aqueous solution to be alkaline. So basically, what causes an aqueous solution to be alkaline? I'm sorry, I keep choosing the black marker. So I'm sorry. OH minus shows alkalinity, and H positive ion shows acidity. This was not asked. Basically, this was not asked, but I'm just telling you. Now, right. So I can give you a reference too because of this question, that H positive shows acidity because we usually have an H positive ions in acids. For example, the main example would be HCl, H2SO4. These are two basic examples. And moving on, talking about what do we call it? Alkalis. I'm sorry, the word slipped my mind. So alkaline bases, basically they are NaOH, the most commonly used. So this has an OH ion, and so this is a base, and these acids have H basically hydrogen atoms. That's why it is acidic. Now moving on, it says the table shows the melting point of group 2 metal oxides. Now when we look at these, when they're moving down the group, magnesium, calcium, strontium and barium, the melting points are decreasing. Now we have to explain why they are decreasing. So let's do that. So basically, when we move down the group, the size of an atom increases, right? So the distance, so basically this is the nucleus and the shells are increasing, right? So the distance between shells of electrons are increasing basically. So the distance between the nucleus and the valence shell electron is more than that of the element with lesser shells, which is the above. For example, magnesium has 12 electrons, so it has only 2.8.2 3 shells. So comparatively, this distance will be smaller than the one which has 4 shells, right? So as we move down the group, the first point is the distance between the nucleus and valence shell increases lesser nuclear attraction. Okay, so basically the shielding is also increasing because the number of shells are increasing. So these shells, the inner shells, can shield the nucleus better as compared to this one. So it is easier to remove an electron. And lesser nuclear attraction and decreasing shielding, so easier to overcome the electrostatic forces of attraction, right? Now moving on to the C part. Oxygen reacts readily with some metals, but each group 2 metal requires strong heating to start the oxygen. Now we have to suggest why strong heating is required. So basically, whenever a reaction is started, let me change the pen's color. Don't we have white? Basically, nope. Now when we when there's a reaction, so there are two types of reaction, endothermic and exothermic. Now this one is endothermic because it is gaining energy, and this one is exothermic because it is losing energy. And this is the activation energy, this one, and this is the activation energy, right? So both of these reactions require an activation energy to start up a reaction. So when large amount of energy will be required, it means that the activation energy is very large. So basically this is the enthalpy change. So for example, taking this example, if one reaction has the enthalpy change of this much, it will require a higher activation energy as compared to the one which has lower enthalpy change. So it will only require this much. So to overcome the activation energy, large amount of energy is required to start up these reactions. Now, beryllium oxide reacts with hydrochloric acid to form molecules of BeCl2. Now, BeCl2 belongs in group 2, right? So, even though you will have the data booklet given, I don't remember what electronic configuration it has. So, why don't we look at Mg? Don't do this. I'm just saying because, okay, don't look at like that. So basically it belongs to group 2, we know that, right? So it has a +2 charge, which means it belongs to group 2, which means it has 2 valence electrons, right? Sorry. So let's draw the valence shell. One is over here, one is over here. And because chlorine has 7 valence electron, it only needs 1 electron, right? So this is Cl, this is Cl. So basically, because this is a linear structure, because no lone pairs of electrons are present, so it is just 180 degrees. Sorry, I'm so sorry. 180 degrees. Now, alright, so unlike the other oxides of group 2 metals, beryllium oxide is amphoteric. I'm sure you know that. So basically, the oxide which reacts with both acids and bases is called amphoteric. Now, let me add the next question and I'll get back to you. I hope you understood till now. Alright, now moving on to the next part. It says beryllium oxide and aluminum oxide have similar chemical properties. The BeOH4 minus 2 ion is a product of the reaction between. Alright, now we have to construct an equation. So basically, what it says is, beryllium oxide plus OH minus ion plus H2O gives us BeOH4 minus. Now we know that it has a molecule of water because why? Because over here it says excess concentrated OH, which has an aqueous sign. So whenever there's aqueous, you can add water if it's not being balanced. Okay, now let's balance it. BE wait BE OH H2O. H2 and O is gone, and 1, 2, 3 O's and 2 O's. Okay. Let me erase this. Sorry. So basically, oops. Right. So nitrogen 2, 3, and how about we put a 2 over here, 2 and 4, 2, 3, 4. It's balanced now. So that's how you balance it. Now next question, it says the magnesium oxide reacts reversibly with chlorine according to the following equation. 2MgO. Alright, state two features of a reaction that is in dynamic equilibrium. So there are two conditions. One of them is rate of forward reaction is equal to rate of backward reaction, and the second one is the reaction should be in a closed system to avoid any loss of mass. Now this is an KP question, is given by the following expression: PO2 PCl2. Alright, now over here there are only two gaseous molecules present. One is Cl2 and the other one is O2. The other two are solid. So in KP we only take the gaseous molecules. Now it says 70% of the initial amount has reacted. So why don't we take a 2 Cl2 and 1 O2? 2 Cl2, 1 O2, and it says that at equilibrium 70% has reacted, which means 30% is left. And because it has a 2-to-1 ratio, 70% has been formed. 70% should have been formed if it was 2-to-2 ratio, मतलब सेम रेशो अगर होती तो दोनों का सेम होना था, लेकिन अब इसकी हाफ रेशो है इससे, ये देखो इधर हाफ है तो इधर बनेगी 35%, right? So 30 and 35. Now I'm not sure what they were asking. We just have to write KP ka expression. So in KP's expression we write mole fraction. ठीक है, तो these are the total mole will be 30 plus 35, which is 65. Now 65%. Now we usually don't take percentages. Let's divide all of this by 100. Now 0.3 over 0.65 and 0.35 over 0.655. Now whatever the answer comes, you're going to write it in the equation with O2 and Cl2 ka square, because over here it's 1 and over here it's 2. So this has the power of 1 and this has the power of 2. So whatever these are, so basically this was for Cl, this will be squared, and this one was for O2, so this will be squared. Now let's move on to the next part. This is not the complete question, so let's add the whole. Now the units basically would be KP. Units of KP would be, so unit of the pressure is Pascal over Pascal square. 1 Pascal will be 1 Pascal would be cancel, and 1 Pascal going to be cancelled over here, so 1 over PA, which should be PA minus 1. So I hope you understood. Now the next part says magnesium peroxide is made in the following reaction. Alright, the peroxide, now this is information given. Now the peroxide ion is O2 minus 2 to reduce the oxidation number of oxygen. Alright, so basically what is written is, wait, O2 minus 2, right? So basically what it is we have to calculate this x and the this x, and the whole sign is minus 2. So 2x is equal to minus 2, which is x equal to minus 1. So the answer is minus 1. Now determine the enthalpy change of formation. This is pretty easy, and so I'm not going to write it, but make sure you memorize it and write the correct answer, because it has 2 marks. Now we have to calculate the enthalpy change of formation of MgO2. Let's rewrite the equation. MgO plus H2O2 MgO plus H2O2 MgO2 plus H2. MgO2 plus H2O. I'm sorry, I don't have enough space. H2O. Alright, now we have to calculate the enthalpy change of formation of MgO2, which is X. So basically let's write the elements over here from which they are formed. So MgO2, Mg plus O2 plus H2. So from Mg and O2, MgO2 is formed, and from Mg plus O2, MgO is formed with half O2, but we are not going to balance it, just writing the elements. From from O2 plus H2, H2O2 is formed, and this is written as it is. So from H2 and O2, H2 is formed. Now we'll just put in the values, minus 602 and minus 188. So minus 602 and minus 188, and we have to calculate this out. This is, for this reaction, the enthalpy change is minus 96, and let me check, water is minus 286. So it's 286. Now all are in 1:1 ratio, so it won't be multiplied. So minus 602 minus 188 minus 96 is equal to x minus 286. Now we'll solve this equation. I'm not going to do that. Now moving on, It says magnesium peroxide decomposes slowly to form magnesium oxide and oxygen. All right. Use your answer. Okay. Now what we're going to do is rewrite this equation as well. So MgO2 MgO plus half O2. Same elements over here, Mg plus O2. So this one is, I think we have calculated this in the previous part. Yes. So for instance, in the question this is given, so I'm taking this, but you can take the exact answer. And MgO की फॉर्मेशन भी गिवन है और O2 सिंपल O2 इधर वैसे ही जो पड़ा हुआ है इधर, क्योंकि अगर आप इसको हाफ कर दो तो सेम बात है. और इसके बाद इसकी भी आपके पास गिवन है, ऊपर क्या थी इधर आपकी 602 -602 और ये हमने x निकालना है, तो -550 plus x is equal to -602. Just solve this and you are done. I hope you understood. Stay tuned for the next question.